sequence that hides a beautiful geometric meaning. Recognizing Riemann sums is a key skill in calculus that connects discrete sums to continuous areas under curves. You'll learn to rewrite a sum as a Riemann sum, convert it into an integral, and evaluate it using the area of a quarter circle. We'll factor n squared out from inside the square root, which reveals a Riemann sum for the function square root of 1 minus x squared. That integral is just the area of a quarter unit circle, which equals pi over 4. Let's work through it on the diagram. Here's a sequence that looks intimidating at first. A sum of square roots divided by n squared. But hidden inside this formula is something beautiful, the area of a quarter circle. Most students see this sum and panic. The trick is to stop thinking of it as a sum and start seeing it as an approximation of an area. Goal: show the sequence converges and find its limit. Step 1. Let's understand what this sum is really doing. Each term's square root of n squared minus k squared is the height of a circle of radius n at the point x equals k. Adding them up gives a sum of heights, like stacking thin rectangles under a curve. We divide by n squared. One factor of n rescales the heights and another rescales the widths. That turns the sum into an average, an area. Now let's rewrite the formula carefully and watch the Riemann sum appear. Step 2. The Riemann sum formula. 1 over n times the sum of f at k over n approaches the integral from 0 to 1. Factor n squared out from inside the square root. That gives n times square root of 1 minus k over n squared. Substitute back into a sub n. The n inside cancels one n in the denominator, leaving 1 over n times the sum. This is exactly a Riemann sum for f of x equals square root of 1 minus x squared on the interval from 0 to 1. Taking n to infinity, the sum becomes the integral from 0 to 1 of square root of 1 minus x squared. As n grows, the rectangles shrink and fill the quarter circle perfectly. Step 3. The integral is the area of a quarter of the unit circle. The curve y equals square root of 1 minus x squared is the upper half of the unit circle. From x equals 0 to 1, the area under the curve is exactly 1/4 of the unit disk. 1/4 of pi r squared, with r equals 1 is pi over 4. Therefore, the sequence a sub n converges, and its limit is pi over 4. Whenever you see a sum that contains k over n inside a function and an overall factor of 1 over n, you're looking at a Riemann sum in disguise. Factor constants out until the sum matches the Riemann form, then replace the limit with an integral from 0 to 1. This bridge from discrete sums to continuous integrals